I'm Anil Kumar, and in this video we'll discuss how to find inverse of quadratic function, especially when it is given in standard form. The question here is, find inverse of the function f of x equals to 5x squared plus 20x minus 10. Explain how can you ensure that the inverse of f of x is also a function. So let's find the inverse of this function. We are given f of x equals to 5x squared plus 20x minus 10. Now, to find the inverse, we have to swap x and y. That is the first step, right? So we need to swap x and y values. That is to find inverse. Is that okay? And then we have to isolate y. So we could write this as x equals to 5y squared plus 20y minus 10. Now how do I isolate y? The only method here is to perform completing the squares, right? So on the right side we'll do completing the squares process, and that is take 5 common, use square brackets, y squared plus 4y, keep this 10 aside, right? And then we have to do half of this number. So 4y, half of this is 2. So we add and subtract 2 square minus 10. Let's continue. Now these three terms form the perfect square, y plus 2 whole square. Plus you take from here, 2 from there. We're left with minus 2 square, which is minus 4 minus 10. Now I'll open the bracket. So we have 5 and we have y plus 2 whole square minus 20 minus 10. And that gives you 5 y plus 2 whole square minus 30. So now we have the function, and from this function we can actually find the inverse. So whenever you are given quadratic function in standard form, to find the inverse, first step is do complete these squares. So that is the steps involved. So remember, complete squares. And then solve for y, right? So now we get the inverse of this function. So let me rewrite inverse as, now it may not be a function, right? So we can write inverse of this function as equals to, now we will find the inverse, right? So we'll let's isolate first. Okay, so this is still, we are far from here. What we have here is, let me rewrite with this ink. So what we have here is x equals to 5 y plus 2 whole square minus 30, right? So that is the function which we have. It has vertex at minus 2 and minus 30. To find the inverse, we have to isolate y. So we'll bring 30 this side. So we have x plus 30 equals to 5 times y plus 2 whole square. Now I'll divide by 5. So x plus 30 divided by 5 equals to y plus 2 whole square. Now we'll square root, right? So when you square root, you have to do plus and minus, right? So you get plus and minus here, and you get y plus 2. And now you can say y equals to, bring 2 here, minus 2 plus minus square root of x plus 30 over 5. Do you see that? So now we can write the inverse of this function, which is f inverse is equals to minus 2 plus minus within square root x plus 30 divided by 5. Now clearly there are two values for each value of x. Therefore this is not a function, right? So this is not a function, right? But this is what you get, right? So the first part was find the inverse of the given function. That is the answer, right? So you can highlight this. That's the answer for you. That's the inverse. Now the question is, explain how can you ensure that the inverse of this function is also a function. So we know clearly this is not a function. So what we can do is we can restrict the domain of f of x. And how do we restrict this? We can restrict from the vertex itself. So if I say that if x is one side of this, that is greater than equals to minus 2, in that case f inverse will be a function. Do you get my point? Only then. So therefore, to restrict the function, what we could impose on this is we could say let x be greater than equal to minus 2. In that case, our inverse will be a function. Otherwise, you can see it is not a function. Well, you could have done less than minus 2 also. That will also ensure, but that will be with negative value. In that case, the inverse of the function will be, in that case, inverse of the function, let me write x this time, will be minus 2. Since we took greater than, we'll take the positive value, positive of x plus 30 divided by 5. So that becomes the restricted function. So one arm of the parabola. So basically what you see here is this function is kind of like this, right? This function is kind of like this. And the inverse over here is kind of like this. And what we did was we restricted our domain and we just took one arm. So if when we say greater than equal to 2, we took this arm, and which translates to the upper arm, right? So that is how we changed. For the inverse to be a function, it should pass horizontal line test. This restriction allowed it to pass horizontal line test, and that reflects into the upper half of this parabola, and it passes vertical line test. So that is how all these things are connected. I'm Anil Kumar, and I hope that helps. Thank you, and all the best.